Hi, so another video today. We are going to discuss a bit more about colors. In other videos we have discussed about different LED arrays and how they relate to your application. So you have LED arrays that are color based, some of them are white based, and I want to discuss a bit more about that and relate that to ways of measuring color and the color rendering. The first thing that we need to understand is the different types of white and color light sources. So we have light sources that are based on color mixing that we normally call dynamic color light sources. So dynamic color applications is when you do a facade, for example, color blending with different luminaires. You are trying to wash with the specific color a facade, and then you're mixing the different colors to achieve a specific color. So mixing red, green, and blue, you can achieve almost any color that you need. That is dynamic color. A dynamic white, it's a different concept that is related to what we discussed about the LED arrays. In a dynamic white light source, you have the possibility of changing the color temperature of your white source. So you can do a more warm white, or you can do a cool white. And you can mix this depending on the application. So, for example, if you have a heritage monument, probably you will like to do it to illuminate it with more warm colors, because that's how our eyes are used to. But if you're doing a more modern monument or a museum, for example, normally you tend to use cold whites, because this matches better with the raw colors that you have in the materials of the paint of the architectural building, or more related to the graphic design that you are using, etc., etc. But there is also the possibility of finding light sources that are single color, which means that instead of using additive mixing, a mix of red LED chips, green LED chips, and blue LED chips, plus whatever other colors you want to add to the mix to generate any color, what you will get is just one light source with one specific LED chip. It might be red, it might be green, it might be blue, it might be amber. And the application of this makes sense for, especially for architectural installation or corporate installation, when you have a clear branding or the building needs a very specific color. Imagine a hotel chain, for example, that has all the corporative or branding image based on green. Then when they illuminate the facade of that hotel, it might be that they want to illuminate it only in that color, in green. So you can clearly identify from a distance, a 3-kilometer distance, for example, when you are driving and you look at the skyline of the city, that there is a hotel of that specific brand in there because it's illuminated in that color. Apart from that, you also have the chance to go for a fixed white light source. And a fixed white light source, it's a light source that cannot change the color temperature. It has a native color temperature that it can be cold or it can be warm, but you cannot modify it anyway. So in the beginning, when you're using this fixture, you will get a lot of output out of it. You can modify it, of course, with filters and any other mechanical things on top. But when the light source decays over time, when it's reaching its lifetime expectation, then you will see that there is a color shift on this light source, and it's not clear which way this color shift is going to be. When you are using a fixed white, the only chance that you have to compensate this color shifting is by using filters. But why is that interesting to have a fixed white light source? Well, definitely in stage lighting, it's a big thing, because in stage lighting, and especially in movie heads, what you need is a fixture that has a lot of energy coming out of the optic, a lot of power. And then this light output, you can modulate it. You can make it wider with the zoom, optical system, or you can put a prism on it, so make a special effect, project different gobos on top of it. And all these things work much better in terms of output, and only in terms of output, when you have a fixed white than when you are doing a dynamic white, a dynamic color, or a single color. All these things are related to light sources, but we have very different manners of evaluating and measuring how these light sources behave. And probably you heard one of the terms that are used more and more and more in our industry. Since many years we have been using it, but now it's becoming very popular, which is color rendering. So what is color rendering? Color rendering is, in general, the method that measures the possibilities of a specific light source to reproduce the colors the way they are. So in my case, I have a blue color here, and my hair is from a specific color, my eyes are from a specific color, and my skin has a specific tone. If you were here with me, you will see, when you look at me with your eyes, you will clearly see the colors, and you will clearly see what's my skin tone, what is the color of my eyes. But the only chance that you have now to guess is through this camera. And in this camera, there is a lot of lighting around. In this case, I have sun lighting and some artificial lighting as front lighting. All of them are mixed, generating a specific color reproduction of these colors, of this blue, of the color of my eyes, of my skin tone. So only if you have a light source that is able to reproduce these tones accurately, you will be able to see the colors as they are. Why this is so important? Well, definitely stage lighting is not that important when you are playing with effects all the time. So sometimes you want to play with the psychology of the color, and you want to generate a specific mood by using a red or using a blue. And when that happens, then color rendering is not playing a big role. But when you have cameras and you have front lighting, then it becomes very important, because if you see a lot of blue in a skin tone, it definitely not reproduces how the person is, and that might be very, very strange for the viewer. Of course, also for the quality of the footage, some of the things will look dirty, or they will look blurry, they will look not very nice if you're not reproducing the colors the same way the users see it normally. So that's more or less what color rendering is about. It's very important when we talk about color rendering to explain that color rendering depends on the method. And this is very important. Color rendering measures quality. It does not measure the quantity of the light. That's something that you do with the lux meter. It does not measure necessarily the color temperature, but it's related to. So it's not really measuring, okay, so you have a 3000K color temperature here. But of course, it's important that when you measure the color rendering of a specific light source, you relate it to a specific color temperature, of course. What the color rendering is about evaluating the quality of a light, their ability to reproduce this accuracy. And you have different methods here. Every method is different. The more common method for color rendering, the one that you probably know more, is called CRI. So the CRI, which is color render index, the CRI is a scale from 0 to 100 to measure the quality of the light when reproducing colors. The CRI is based on 8 samples. So basically, it's like having a card where you have these 8 different colors, all of them the saturated colors, because at the time the CRI was designed, the system was designed, it was not that important, or it was not thought at that time that saturation would be a parameter that would be used in the next years. And that's why the CRI does not focus on saturation. These days, it's becoming more popular, the TLCI, and the TLCI means Television Lighting Consistency Index. So the difference between CRI and TLCI, it's basically that in the CRI, there is no software involved, there's no cameras involved. It's just a measurement, and that's it, and how these colors are reproduced. But in the TLCI, it's the software itself who analyzes how these colors are reproduced. And this is very related to cameras. That's why it's called the Television Lighting Consistency Index. It's designed to match the characteristics or the specifications that you will have in a CMOS or a CCD in a camera to reproduce those colors, and how that interacts with the lighting that you have. Normally, fixtures that have a very high CRI, let's say 90, even 95, they don't perform very well in the TLCI rating, which is, again, a scale from 0 to 100. So, we have seen the CRI, we have seen the TLCI. There's another method that is becoming very popular these days, which is the TM30-15. And this method of measuring color rendering has been released by the IES, Illuminating Engineering Society. I don't know how you say it in English. But basically, in the TM30-15, you have three aspects that are very important. One is fidelity, another is gamut, and another is the color vector graphic. The most important thing here in the TM30-15, if you compare it with the CRI, is that instead of 8 samples, here you have 99 samples. So that is the big difference here. Similar, some of them probably remember that there was a never released CRI system, that was the CRI 96. So the idea of having 99 samples is that, of course, you will have a better representation of the colors. You will know better how this light source will be able to reproduce not only the saturated colors and very key colors, but also saturated colors and hues in between. So the more samples you have to compare it against, in theory, perfect light sources, the more chances you will have to say, okay, this light source is very accurate. So, interesting thing about these three systems that are compiled into the TM30-15 is, first, the fidelity works pretty close to what you have in the CRI. Pretty close, also a scale that is more or less telling you more or less the same information, okay, in terms of quality. But the big thing here is the gamut, because the gamut is giving you information about the saturation. So it's telling you how saturate the color is, or how they saturate. And the color vector graphic, it's representing in a somehow of color space, it's telling you how the saturated and the saturated colors are behaving in this particular light source. So the combination of the three gives you a lot of information that the CRI is missing, and that's why the TM30-15 system is very, very interesting. We didn't say it before, but it's important to understand that in order to analyze this, you don't need a laboratory, of course. You can have a spectrometer, and these days it's quite easy to get or to buy a spectrometer. You have it from many different brands and in many different formats. Some of them are very portable, and more or less every spectrometer these days has the possibility or the chance to give you CRI values, TLCI values, and TM30-15 values.